Hello, in this video we're going to explore the simplest possible communication from Texas Instruments MSP430 to the STM32 board, and so for this purpose we will send only one character from the TI to the ST board via UART, of course. Our setup is as following. We have one computer connected via USB to the MSP board and to STM board. It's two different USBs, and between those two are connected with the UART, with wires for the UART communication. This is an exact number of the LaunchPad of MSP430 that I'm using, and this is an exact number for the STM32 board that I'm using. Here is the detailed pin-to-pin connection for the UART between those two boards, where TX obviously connected to RX and RX connected to TX, and they have the common ground, but you have the exact pin numbers which are connected, and you can see, for example, here you see PA10 pin number 33. You can go over there here, and you see pin number 33, this one, and this is corresponding to PA10. So you can and so on with the you can see P1.2 and P1.2 and P1.1. So by using those two schemes, you can easily connect pins according to this schema. Okay, now we will write a basic code for the TI board in order to send one character via UART. And so we are in our Code Composer Studio. Now we will start a new project. Create new project. Now it's loading the new project wizard. We will choose our board, which is MSP P430 G2 ET, this one, and we will take some empty project as a template. This one, we will call it send char UART create. Okay, while it's creating the project, let's go to the GitHub repository and to see which code is available for this project. So this is our main. Okay, the project is created. We really don't need the LCD driver. We can delete it just to keep it simple. Yes, and also we don't need the images. We can delete it just to keep it simple. Yes. Okay. So we're working with our main.c. Now let's go to the GitHub. Inside Sims IoT Devices GitHub repositories, we will go to TI MSP430 And we are looking on the second case, basic UART communication example, where in order to transmit one character, we will use this file. We'll copy this file and go to our Composer Studio and paste it here. What this file basically do is stop the watchdog timer, which is done in every program for MSP430, and configure clock for 1 MHz, configure RX and TX pin, which is 1.1 and 1.2, configure the bound rate, this one, remember we want to be consistent, and initialize the UART according to the TI requirements. Our program is a 3-line code program while we are waiting for the register to be ready, and then we are sending character T, like TI, to the UART, and wait for 1 second. Okay, so let's run this code, project build. Okay, finally the build was finished. Now we can flash the project. Flash. Okay, that's it. Now we have finished the flash, and let's go to the STM32 in order to define projects that can receive this transmission. Okay, now we're going to build an STM32 project in order to receive a character. We'll go File and New STM project. While it's building, in parallel, I will go to the relevant repository in the SIMS IoT devices in GitHub, which is in our case TI MSP430. And we are looking for the second project, a basic UART communication, where we want to go to the file for the STM32, which is STM32 UART receive. It's also written here to receive a character. Okay, so we're going here. Please remember that we cannot just copy it into the project, because every project in STM is done automatically differently according to the board that you are using. So we will only copy the relevant snippets. Okay, so let's go back to our project. Okay, now we want to define the board that we are using inside the STM Cube ID environment, which is nuclear. We have nuclear, this one. This is my board, this one. And okay, next. We will call the project MSP430 UART STM32. Finish. Yes. Now it's building the project automatically according to my specific board that I'm using on STM32. but this method is relevant to any board that you are using. Okay, so let's go back to while we are waiting to the GitHub. Sorry for jumping. I just want to be more efficient. Look here, those are not changing, and you see the only snippets that we are talking about, it's begin code. Here we have nothing to add, and the first begin code that we are changing something is here, the user begin code number 2. Okay, so we are going back to the ID environment. First we have to define additional UART connection. The first UART connection here is used for our USB connection to the board from our PC. So we will take this one, UART RX, and this one UART TX. You see, we defined those two pins. Now let's go to the connectivity and enable this UART1. You see UART1, and this is UART1 here, and we will put it like asynchronous. Okay, now we can generate the code. So we will save our project. Those became green, so we are saving our project. Do you want to generate code? Yes. Do you want to open? Yes, we want to open this window. And now we have the STM cube ID opened with the relevant project that we just created. So here we will put the relevant snippet. We will not end anything in user begin here. We will go to the user begin to here. Okay, so first in the user begin here, we will take this code and paste it here. Basically what is doing is giving a live signal. So we define the string empty and transmit it to the screen via UART2, which is our USB connection. Then we define variable which we will receive of one character, which we will receive from the TI board. Okay, I'm going forward. Here you can see inside user begin 3 we have those 3 lines. We'll copy them, and here inside user begin 3 we'll paste those lines. What are basically they do, we receive from UART number 1 a character. You see RX data, it's only one character, and then we transmit it via UART2 to our screen so that we can see that we actually received it, and then we will wait for 1 second. Additionally, you can see here that the bound rate that we are working is 9060 in both UARTs here. And where is the other one? Here. So we will go to our IDE, go to the automatic UART definitions, and we'll update the bound rate to the common bound rate. It's not important what the value is. if we are consistent in this. Okay, we will save it and build the project. Okay, it's finished, and now we will run the project and flash it on our board. Okay. STM boards are very comfortable, so you actually can see via the LED the debugger is working. So now it's finished the flashing of the data. Now we want to see the actual characters that are transmitted. So first we'll open our device manager and see where those ports are connected. Here you can see that STM is connected to COM number 8 here. So we will open PATI with serial communication. The defined speed is 9600, number 8. Open. Okay, so you can see the T is transmitted from the TI board to the STM board. Now let's run it again just to see how will it work. I'm flashing it again. And I want to show you something here. Yeah, you see, this is empty string. This one, the empty string, the first time we have flashed it, it's run the empty, put it on the screen via UART number 2, and then starting to receive with infinite loop the character from the TI. So now we have demonstrated the transmission of one character via UART in the simplest possible form from the TI board MSP430 to the STM32 board, and that's it basically. Thank you.